Hey, hello there. My name is Jeff Fritz, and welcome to .NET Conf Focus on Microservices. We have a full day of terrific content for you all about .NET, microservices, containers, Kubernetes, and we've even got some new tools that we want to show you along the way here throughout the day, live as part of another one of our .NET Conf Focus events. Now, there are all kinds of speakers that you're going to hear from throughout the day today, and it's your chance to speak to them, whether it's here on Learn TV, it's over on the Focus.net Conf website. Maybe you're watching us on Twitch or even on YouTube. We're going to be streaming to all of those sources concurrently so that you can catch up and see what's going on and talk to the speakers and learn a little bit along the way. So, if you want to ask questions, if you want to catch up and mention anything, you want to talk about what's happening right here on .NET Conf, head out to Twitter and use the hashtag .NETConf. And we'll pick those up. We've got a tag board. We're going to review and show and share your questions with some of our speakers so we can get answers for you and you can get that great feedback that you're looking forward to. Now, we have digital swag available for you as well. Check it out. Head out to aka.ms/.netconf swag. And we've got some fun mouse cursors, phone, and desktop backgrounds there for you. All right. Now, we've got just a few seconds more before I bring in our keynote speakers. We're going to be talking to them throughout the day today. Well, for at least this first hour, we're going to hear from them. But we want to hear from you right there on Twitter. Make sure you use that hashtag so that we can relay your questions, pick them up on our tag board, and share it with our speakers. So grab a beverage, make sure you have some water, make sure you have maybe a nice cup of coffee or a cup of tea, whatever time it is in your time zone, so that you can join us and enjoy all of the great content we have for you. Now, our first speakers, our keynote, we're going to bring on, we have Scott Hunter and David Fowler. They're going to introduce the day for us, and I'm going to send it over to them right now. Scott and David, you're up.
Awesome. Thanks, Jeff.
Hey, Jeff. Thanks.
So welcome to .NET Conf, focus on microservices. I'm Scott Hunter. I'm the Director of Program Management at Microsoft on .NET. You can follow me at @CoolCSH. And David?
I'm David Feller. I'm an architect on .NET. I'm going to develop microservices.
Okay, so let's get going. We always start .NET Talks with, when I joined Microsoft in 2007, .NET was primarily about desktop and web. And today we've added cloud, mobile, gaming, IoT, and AI. We think .NET is a platform for building any app you want to build. It's great for all those types of apps. We've had a lot of awesome momentum in .NET. We shipped .NET Core technically around the beginning of March of 2017. So we're about 3 years into the journey, a little bit over 3 years. We have over 1.5 million .NET Core developers today. We've been the most loved framework in Stack Overflow's developer survey in both 2019 and 2020.
Scott, you know what? That is really awesome. Can you do me a favor and share your screen?
Oh, that would be nice, wouldn't it?
I was like, where are the slides?
I always start these things off with a little entertainment here. How are we doing, Jeff? Slides?
Awesome.
Okay. Let's make Fowler go away. So back to that momentum. 1.5 million .NET Core developers in the first 3 years of the product shipping. 2 years in a row, most loved framework on Stack Overflow developer survey. And as I said, we open sourced around 2014. And since then, we've become one of the top 30 highest velocity OSS projects. Top 5 language on GitHub. And we take part of this performance benchmark, a public one that we don't run it here. It's actually run in the cloud by some other folks. And we are 7 times faster than Node.js. So it's, performance is a huge part of .NET for us. And when we look at the people that actually come and download our product for the first time, we're finding that a lot of those are students that are learning to program and using .NET as their the first choice. Some other amazing things is .NET adoption. We have 5 million .NET developers today. We've been growing at about 1 million developers a year for the last couple of years. And in the last year, we added 600,000 brand new .NET Core developers. And even more amazing is, as I said, we've only been on this .NET Core journey since about 2017. And that's the version of .NET that actually opened .NET to Windows, Mac, and Linux, and many other platforms. And we already have 2 million people, or 2 million publishes to Linux from our tool chains. So it's showing that people are adopting .NET on Linux, which makes us very excited. .NET Core 3, which we shipped at the end of in November, or just or technically September of 2019. We shipped our LTS in December of 2019. It's the fastest version of .NET that's ever been adopted. I mean, what I mean by that is roughly 2/3 of our developers at all tried .NET Core 3 in the first 6 weeks of its shipping dates, which is amazing. We want our developers to be on the latest tech, and that was a tenet of .NET Core, was you could install the latest one without breaking anything else. And so we're seeing that adoption. I mentioned before, performance is key to our platform. We want to make sure that no matter what you're building in .NET, you get the best performance no matter what technology you use. So if you look here, you can see as we look at .NET 5, which is the version that's going to ship this November, 30% socket performance improvements on Linux over .NET Core 3.1. We're always working on trying to get JSON serialization to be faster. You can see 20% improvement over .NET Core 3.1. For large collections and arrays, 3 times improvement and 0 allocation of memory in the process here. And then one of the things that David and I are going to talk about today is a technology called gRPC, which is a great way of doing contract-based RPC calls. You can see here that when it comes to the client, we have a super performant client, more performant than gRPC on Go. And you can see on the server, we are super performant as well, just a little bit over the performance of Go. And I think it's amazing. We just shipped gRPC support in .NET Core in the 3-wave. So it's pretty new.
And that isn't all. We actually had a blog post that Stephen Tobe wrote on the .NET blog that actually shows a ton of performance improvements around regular expressions and other things. So this is just a few of those a snapshot of those changes.
So .NET Core 3.1 LTS, it shipped, as I said, December of 2019. And our ask to our developers is build all your new .NET apps on this today. It's the stack to build if you're building new applications. And we have preview 7 of .NET 5 that's out there right now. Once again, you can install these side by side. So installing .NET 5 Preview 7 will not break anything, and you'll be still good to go. But if you want to try some of the new stuff, please download and try that. I want to quickly talk about how we ship .NET. We used to ship .NETs kind of on some random cadence of whenever we were done working on some features or something like that, and it made our support story kind of complicated. So we want to be very clear to our customers. We're going to ship .NET every November. And then every other year, it's going to be what we call an LTS release, or a long-term support release. So it means if you want to stay on 3.1 or 6.0 or 8.0, each of those comes with 3 years of support. If you want to be on the bleeding edge all the time, just grab the yearly release whenever you want. But the hope is that this makes it very predictable when the next release is going to come out, and you don't have to guess. We have our big launch event, .NET Conf 2020, which is going to happen November 10th through the 12th. We're going to launch .NET 5 there. It's a 3-day virtual event, and you're going to see here, call for content is going to be open. It's not just us talking at .NET Conf 2020. It's also a bunch of the .NET community. So please mark your calendar for that. And I want to call out, we have some amazing speakers over the next 2 days. We've got Brendan, Kelsey, Julie, David, all speaking today. That's going to be amazing. And so after David and I are done, please stay on the line so you can actually hear from these folks. And with that, let's talk about what are microservices.
What are they? So microservices is an architectural pattern, and it's mostly about scaling teams as your app grows in complexity what you want to do is figure out how to split your application into loosely coupled components so you can deliver value to the business more quickly. And the reason for splitting it across boundaries is to have teams run independently so they can deploy their services without having to worry about each other. So traditionally, Scott, if you were to hit the slide, you see deploying a monolith would require deploying the same service to all of your servers. With a microservice, teams can run individually, deploy their services, and scale them independently.
Yeah, to me, the way I think of this is, when I first started building software, we'd have one huge monolithic team that built an application, and we all had to synchronize and ship it all at the same point. The idea of microservices is really to break your project up into groups of stuff, and each of those teams can actually ship their thing on their rate of speed,
on their own cadence, right?
Not waiting for that huge monolith to happen. So it's a faster, more modern way of doing development.
Right. Let's talk about containers. And why they're important for this technology. So historically, your app definition and dependencies were kind of split across your application tier and the VM itself. So if you want to install some software, you have to combine your application configuration with something like Chef or Puppet for deployments. With containers, Scott, if you were to hit the slide, containers let you describe your application dependencies from the app down to the actual OS dependencies in a single immutable format. So I can describe my application and its dependencies in a simple way that has now become a standard across the industry.
Yeah, I was going to say, my take on this, David, is the on the left, virtual machines. That really is take a machine you have in the office and basically kind of copy it as it is to the cloud somewhere.
Right.
The problem with that is you have to actually manually configure the host OS or the guest OS yourself, and then you put your applications on top of it. I'm a really big fan of containers because I in a single file, which David said is kind of standardized, I can actually declare how to build my OS and my dependencies on top of that without having to manually do that. So that's a lot of work that disappears. It also means I can share my Docker file or my container file with David, and he can run it on his machine, and he'll magically have the same environment in just a few minutes.
That's awesome. Yep. So traditionally, you'd have operators deploying apps to VMs manually. So you'd have a load balancer set up between your applications. You would deploy the applications to every virtual machine manually. Scott, keep going with the slide.
Yeah, I was going to say, look, if I look at that big gap, David.
Right. So having a human having to schedule or deploy applications to machines means you may end up with low resource utilization in some cases. With containers, we have a standard format and standard controls for resource management and for packing applications onto machines. So you can kind of move your app and make it more modern where it can support other container platforms. And you can use standard controls to limit resource usage and potentially push applications onto more VMs, or I guess less VMs, to take advantage of the space you have.
Yeah, you can more tightly pack that VM. Today, on that previous slide we were showing, you got this app in this virtual machine. Let's say it's a huge virtual machine, but you don't have a lot of requests. Well, you've only got one app per virtual machine. That's kind of a waste of resources. And then over here, we're showing I can kind of start filling that virtual machine with container tech with more applications.
Right. Great animation. These slides are awesome.
Yep,
and potentially I can remove other resources that are unused, so I can better use my cores, save money.
And you see here by 2022, over 75% of organizations will be running some form of containerized applications in production. So we're seeing those benefits that David just showed you. People are seeing those benefits and using them to actually improve their applications and use less resources. What's behind this growth? This is kind of interesting. Kubernetes, once again, is an orchestration engine. As David was going through the slides, and we showed those virtual machines running your applications. Well, as soon as you moved all that work into that single box, well, what did that? That's an orchestration engine. And there's the most popular orchestration engine today is Kubernetes. And you can see here that huge companies like Capital One, eBay, SAP, Spotify are all using Kubernetes today. And why? Well, one of the main reasons is it's vendor neutral. You can see here, it works in the Azure cloud, it works in AWS, it works with Red Hat, VMware. It is not tied to any particular provider, which means as a company, you can use that technology and not worry about where your app's going to be hosted. And it's also, there's a huge active community around Kubernetes as well. And so you can see the number of contributors and contributions to it since it was built. And that's why we're seeing this become popular. Now, I want to scare you a little bit here. And this is a crazy slide kind of showing how Kubernetes works. And you're going to see lots of boxes and lots of arrows and lots of stuff. Wow. I'm kind of like David. I just like to work on my code and get my code in the cloud. And this honestly scares me a whole bunch. And so when I see this, I'm like, eek. And one of the cool features we're going to show you today is, one of our goals with .NET is to basically give the best developer productivity. You can build the best application and you can do it with the least amount of hassle. And so we're going to show you some of our technology called TIE, which will let you develop locally and do all this stuff you see in this crazy slide, but not have to worry about it. That's David and my job, is to go and take the hard parts of building cloud applications and simplify them down with .NET. So let's talk a little bit about the investments in .NET in the microservice and containerized app space. First off, REST APIs. The world runs on APIs. We all have smartphones, and you're checking your sports scores or the news or whatever. And when that happens, your device is out there pulling some API somewhere in the world. And we have amazing tech in .NET around this. We're going to show some demos of it later today. One is we support the Open API standard, and that is a way of describing a REST API. And that allows tools to work, client generation to work, and so it's an important part of this. I have something called the API REPL, and what that is that's an environment. Traditionally, .NET applications were client applications, whether it was a desktop app or a web app. Starting your debugger and having it show you a blank web page isn't very useful. And so we have an awesome feature in .NET called the REPL, where you can actually launch your API into a command line interface where you can see all the list of your APIs, you can call them and debug them live in our tooling chain. Client generation, that's another part of this. If you've been using .NET or you come from using .NET Framework, you might be used to things like WCF, where you could basically write a service, and then you could just right-click on that service and say, generate me a client, and you could easily call that service. We want to make that same capability available to REST. And so we'll demo a little bit later on. I can right-click on an API and generate a .NET client. Now, the cool thing about Open API, because we're using Open API, if you needed to, you could take that same Open API spec from your API and generate a client for Java or Node or any other technology. And so it truly lets you build clients across all the platforms. And then finally, there's some pretty awesome capabilities in Azure for hosting APIs. And we're adding support in Visual Studio to let you publish directly to Azure API management. The next thing in cloud-native investments is gRPC. I think of REST as being, this kind of standard. It's been open up for a long time. It's kind of text-based. It's meant where you can actually change the API over time and not have to update the client. But that said, a lot of our customers actually like having tightly bound clients. You're coming from WCF or one of our remoting technologies, and gRPC does that. But gRPC is a little different in that it actually is supported across all the tech. So you can have a gRPC service in .NET and call it from Java, call it from Python, call it from language of your choice.
And one big difference between the two is that you'll see gRPC be used intra-firewall, so intra-cluster, and you'll see REST APIs being used as your public API surface as a big thing.
And once again, we're going to offer the same features for gRPC that we offer for REST, meaning that we're going to let you, in gRPC, there's a file called the proto file. It's where you define what your service looks like, and it has to be its own format because this is cross-language technology. And then from that, we can generate the server for you. So you just have to override some methods, and we can generate a client for you. So you can just easily call that service. And then once again, because it's .NET, you've got world-class performance. I mentioned earlier, one of the missions of .NET Core was to let you build cross-platform applications. And there's been some pretty amazing technology that we've released inside of Windows earlier this year, something called WSL2, which is the Windows subsystem for Linux. And what that enables me to do, I can be on my Windows machine, and inside of Visual Studio or Visual Studio Code, I can compile and run my application on Linux just as fast as if I was on a Linux machine. So you can stay in the familiar Windows environment you're used to and develop on Linux, and you're running native Linux. And we'll demo that in a little bit. Microservices. David and I both hear this all the time, that customers are telling us, especially on public social networks, that .NET's too big for building microservices. And I always laugh, what is too big? Like we're going to show today, a microservice written in .NET Core using ASP.NET, we can shrink that down to 30 megs or less. Is 30 megs too big? The notion that .NET is some like 1 gig huge framework, is that those days are over. .NET Core, you only ship and use what you actually need. We can take that microservice, we can crank it down to a single exe, so you don't have to have .NET on the machine. You can just deploy the single exe to the machine, and using a new C# feature in C#9 called top-level programs, we can get rid of all the ceremony of building a C# program and just have your actual microservice code there and nothing else. We also find that with all that work we've done in performance, we've started building a high-performance reverse proxy called YARP, yet another reverse proxy in .NET to support many of our internal teams. It's once again, it's a show that .NET is fast and performant and good in this space. And then I think the coolest demo is going to be later today, and this is something called Thai. And when I showed that Kubernetes slide with all those boxes and all those diagrams, the whole point of Thai is to enable you to build microservices, which is, for a .NET developer, that means you're going to have more than one application. You might have two back-end applications. You might have a front-end application. You might have a service that's not even any of your code, whether it's, it could be like a Redis cache. How do you run all those things locally? Do you have to write Docker files and all the goop to do that? And we're going to show you that with .NET, we can push some of that stuff away and enable you just to build your apps and run them and debug them locally, and easily deploy them to the cloud. And so I'm super excited about that.
Yeah,
and I'm going to let David talk to the slide about Thai here.
So Thai aims to be a tool chain to simplify microservice development and deployment. And the idea is to basically add some veneer over things like service discovery. Scott, can you keep going? The slides. Yeah, support things like adding dependencies, Redis and SQL. So the idea is that if you want to run and test your microservice locally, you have dependencies on databases, caches, other services. So you want to be able to describe your entire topology, or at least for your one service, in some kind of format. So I can describe my service dependencies for my applications and my dependencies on SQL and Redis, et cetera, without having to learn Docker file support or Docker syntax, I should say. And I can run a debug locally on the machine or in a container. And I can also run in Kubernetes running locally. And then as a final step, I can actually deploy that up. Oh yeah, dashboard. The local dashboard shows logs and metrics and shows me my application topology. So I can see my services all running locally, what ports they're running on. And then as a final step, I can take my application definition that I have locally and then deploy it as a whole to Kubernetes, right? Running either locally or AKS or in any cloud that runs this thing.
Yeah, so to go back to these again, the way I think of these is when service discovery via configuration conventions. How many developers have actually, built a front end and a back end and got confused when, oh, I forgot to put something in a config file somewhere, and so the front end can't find the IP address and the port of the back end.
Right.
Thai will do all that for you. Add dependencies. Historically, if you were going to build a .NET application, I know David and I have both done this. Hey, let's go install a copy of SQL on our developer box. let's go see if there's a Windows version of Redis we can install in our developer box. Yuck. I love Tide because I just say, a couple lines of text, and I have a Redis cache. A couple lines of text, I've got a SQL. By the way, that same SQL will work on my Mac.
Right.
So that's super cool. I can do inner loop development, running and debugging outside of containers, inside of Kubernetes, all without really thinking about all the mechanics to do that. The dashboard thing is something I don't know why we haven't done this, David, in like the whole existence of .NET Core. Being able to actually run your app locally and see the logs.
See logs.
Yep. Once you run more than one app, David, in .NET it's damn near impossible to see the logs without having windows all over the place.
4 consoles up to see things. Yeah.
And then I love the final one. You just type, tie deploy, and your containers go up into your container registry so they can be run in Kubernetes or whatever. So super exciting stuff. Now, of course, you don't want to hear David and I just sit there and rumble against slides all day. So let's do some demos. Ooh. And so first demo I want to do today is I'm going to drop down here. Hey, Jeff. And we will do a web API. So what I've got here is I'm in Visual Studio, and I've built a default API project. And we give you a simple get method that returns the weather. This version of the app is a little different than the stock one. We're going to fix that later this year. But if under my dependencies here, you're going to see I've got a package, and I've added Swashbuckle. And Swashbuckle is a package you can grab today. Just grab swashbuckle.ASP.NET Core. And what that will do is that will add support for OpenAPI to your application. And that's going to enable some of the things that I'm going to show today. So if I just took this app as it is here, and I run it inside of Visual Studio, we will do the right thing. We'll open a browser tab, and we'll show you the results of the API, which is good. If you have one API, if I had 25 APIs, this is not so good. But we have a couple of cool techs here. I can take the app here, and I'll just take the URL. Because I've added Swashbuckle, I can come here and say Swagger. And because Swashbuckle is installed, I get this awesome web interface where I can go look at my APIs. Once again, simple app, so I just got one. I can click weather forecast, and I can try it out, and I can run it right there and see the results. So this is not bad. Just by taking that app, and if I had more than one API, I can launch a web window here, and I can try the API out. Now, I can also click this link here, and this brings up a Swagger definition or an OpenAPI definition. This is a JSON file that describes my API. It enables that UI that you just saw to happen, but it also enables more things. I can right-click on this, and I'm going to save this over here because I'm going to want to use this a little bit later on. So I can take this definition, save it. It's exposed as an API you can see as well. And what can I do with that? So I'm going to close the browsers out here. And what I'll do now is I'm going to go up here and change my IS Express to the HTTP REPL. And so there was that web interface that I showed before. This is going to give me more of a command line kind of interface. And so let's put a breakpoint in my API. And I'm going to F5 the application. And now notice command prompt comes up here. And now I can just type regular commands like give me a dir. I'm in the weather forecast folder. I can jump back up to the top if I wanted to. I can run a get. When I run the get, notice my breakpoint hit. So I can run this, step through my API, all in our tool chain. And you see I've got a great inner loop right here where there's the results of the API. So whether it's going to a web interface, which requires a lot of clicking, or I can go to the REPL, which I can just easily just type get commands, post commands, stuff like that, to easily exercise my API. Our goal here is to make building APIs in .NET even better.
That's super cool.
let's stop debugging and let's build a client. So I'm going to go to my solution and I'm going to right click here and I'm going to say add new project. And we'll build a console application here and we'll call this client. I want to show how easy it is to call that API from .NET. So I've got a just regular console application here. And what I would do next here is I'm going to right click on my app. I'm going to add, and I'll go to service reference. And this is new tech that we built in .NET Core 3 timeframe. Notice I've got this service references Open API or gRPC. I can click add, select Open API. I can give it a file or a URL. In this case, we'll give it a file. We'll take that same Swagger I saved before, open it up here, click finish. And now what's going to happen is our tool chain is going to go out and grab any of the NuGet packages required to use that API, stick them in my project. And so now if I wanted to, I can click these ellipses, view generated code, and you can see all the goop that we wrote for you to call that API to make it super simple. You don't have to write this. Is that awesome, David?
Yeah, looks super efficient too.
So now what I've done is I quickly put some stuff here to write a client. Got to fix a few things. We'll add that. Wants my method to be async. We'll do that. And so if you look at this code, all I really do here is I new up an HP client to call something. I then new up the generated Swagger client, giving it the HTTP that I just did. So you could, set some options on there and have that ready to go. And then I just call client.weatherForecast async. And then I can just loop through the results. So you saw I have an API. I want to write a client to call it. Super, super simple, super fast to get it to run. And now I'll show you one of the frictions that Dave is going to show in a little bit that we fixed. So if I run my API again, there we go.
I love that hard-coded port, Scott, in your,
I'm going to turn the
program
off here. Yeah, that hard-coded port, that's going to come back and haunt me in a little bit. So that's not a good thing. Let's do that. There we go. So I ran the API, but Visual Studio is not great today. We're going to fix this at running lots of projects. So I'm going to right-click over here, and I'll say debug, and we'll say step into a new instance.
It's kind of painful, right? Running two applications to test the client server.
Every time I do that, starting one, starting the other one, clicking through here, and now I can actually just kind of come through here, and we can write the results of that out.
Nice.
Which is still pretty cool. I mean, if you look at my output window there, you can see the weather coming out of there. So I was able to easily build an API in .NET, debug and test it, and build a client. All awesome. A little friction at the end, as I started trying to run multiple projects. And I said, in a few minutes, Dave is going to show us how we can easily do that with Thai. So let's close that out. And let's switch over to gRPC. And so for gRPC, same kind of scenario. I've got an application, and we'll just run it real quick. And you can see it starts up. It's running once again on a port, but it's a little different because it's gRPC. And I mentioned before, gRPC is kind of platform neutral RPC. I have to define my API in a format that's not C# or C++ or Java. It needs to be something that we can generate all those different texts from. And so here you are. I've got a weather response. You can see it's got a date. It's got two temperatures and a summary of what the weather is. And I've got a method here that's basically get me a weather stream. And you can see I call it with no parameters, and it returns a stream of this type. Now, once I've done that, what I would do is I would right-click in my project again, like I showed before. I would do add service reference. In this case, I've already done this for myself. And notice that it says here, let me just zoom in, weather-server. And so what this has done for me is it's actually generated the server code And if I look here, I can once again view that generated code. Here's a bunch of gRPC goop. We don't want you to have to write. All we want you to write is this method right here. Notice public virtual get weather stream, and it's abstract. This means you have to write the code for this. We just write the shell of it. So this file, which you never have to look at, writes all that goop for you. And then all you have to do is go in for your service, and basically you're going to see here I override that one method, and then write my code to return the weather. So you build your proto file, you generate the server code, and then you override the class and write your method. Great. So I've got my service. Now, once again, let's go do the same thing we did before, and let's write a client for this. So I'll do add new project, and we'll do a console application again. We'll call it client. Do a create. There we go. And I'm going to do the exact same steps again. I'll right click. I'm going to go do add. And by the way, everything I'm showing here, you can do from command line as well. So this is not limited to a Visual Studio experience. If you want to use Visual Studio Code, you want to use Writer, you want to use a command line, all of those are supported. I'll do add. This time we'll select gRPC. And I'm going to say, let's go find that proto file that we had before. It's in here. Unlike the Swagger file we had before, this is a proto file. And you'll see on the dropdown, I can say, build me a client, a server, both, or messages only. I'm going to say I want a client. And once again, we're going to do the same thing. We're going to go out to the internet, grab the right NuGet packages for you, and we're going to generate some code for you again. There we go. We're done. And this one, once again, if you want to see the code that we generated, here you go. You don't want to write any of this. Go back to my program CS, and what I'll do here is the same thing I did before. There you go. It's going to complain here. Let's fix a few of these. And it's going to want us to be async again.
More hard-coded ports.
More hard-coded ports.
I love it.
Yeah, that's going to work. That's going to work great in production, isn't it, David? When I go and take this thing and go, let's go put this in the cloud. Okay, so I fixed a few things here. I'll quickly just kind of describe the code. It's pretty simple. I create a channel, and that's kind of where I define the IP address and the port that I want to call on. I new up a client, just like I did before in the REST case. I just called a method on the client, client.getWeatherStream. That took an empty parameter, so I passed nothing into it. And then I basically can loop through and run the application. So let's try that. Okay, you got the server running. And once again, this is kind of clunky. I'm going to go here and take the second project and say step into a new instance. And now I can basically F10 through the app. And you'll see the same stuff before. Very simply, I was able to go build an app. It's displaying the weather the same way. That's the productivity we give you at .NET.
Awesome.
Let me stop that. I'm going to do 2 more quick demos, and then we're going to jump over to David and let him do an awesome Tide demo. So I'm going to close this window out as well. Let's see if we can see Fritz again. Hey, Fritz.
Hey, Jeff.
Okay, let's talk about microservices in .NET. And once again, we talked in the earlier slides. David and I talked about .NET has this history of being this large framework and building huge applications. Take a look at this. This is a .NET microservice written in about 10 lines of code. The actual microservice itself is 1 line of code. It's kind of like, hey, when I'm called, do this. It's a hello world, but David's going to show a much better example of this with more functionality in a little bit. But the point we want to make here, if you've never seen .NET or used .NET, you don't have to write lots of code or use huge frameworks. You can, .NET's amazing in that you can use as much or as little of the framework as you want. If I run this application, it's going to complain. I don't know why it complained, David.
That is strange.
Not right now. Thank you. Let's try one more time.
Try running.
I'm going to cheat. I'm going to use Kestrel.
Let's use Kestrel, yeah.
And we'll run it again.
Boom.
Cool thing about .NET, I can use the built-in web server. I can use .NET's web server. There's my Hello World application. Super, super fast, super simple. But I want to show something. You know, before we were asking that question, David, what's the right size for a microservice? What would you say, David?
30 megs.
So I switched to a command prompt over here, and you can see I ran .NET Publish. I said make a release version for Windows Windows x64, and I passed two flags. Make a single file. This is a new feature that shipped in .NET Core 3, where you basically can pass a flag, and we'll take .NET and your app and shove them into a single file. And then I added another switch here called Publish Trimmed, and that's where we go through and figure out what parts of .NET you're not really using, and we remove it. And this lets you actually build pretty small applications. So if I jump over here, I happen to have a Explorer open up in this window, and there is my 29 meg .NET microservice. I showed this at build, and I showed even smaller. I was sub 20 megs, and I want to show it is real. I double clicked it, it runs. I can grab that. The app works. So if you thought you had to build, 100 meg or 1 gig microservices with .NET, that's just not true.
Right.
One final demo, and we'll switch to David. This is how I want to show a feature that how fast you can build applications that run on Linux. So I'm going to run this again. Now look at this. Boom, that was very, very fast. This is running a simple web application in .NET, and it's showing what it prints out here is the environment.os version. So you can see that I'm running this on Windows, and so it's going to show Windows. Then what's cool here is my machine has WSL2, Windows Subsystem for Linux 2, installed on it. Because of that, I've got an extension added in my VS. Notice here, WSL2, I can change my run environment to that. Now what that means is when I run my application now, it's not going to run on IS on Windows, it's going to run on the Windows Subsystem for Linux. So let's run this. And look at that. Now my app is running on Unix on my same machine. And the startup perf is really, really good. Almost as fast as the Windows startup perf. Now that I've got it loaded once, boom, just comes right up. And it's not just that you can do that. Notice I have a breakpoint here. I can run the debugger, and now I'm actually debugging on Linux on Windows. There's the breakpoint hitting. I run the breakpoint. There I am again. And that's just, we're showing you that, you can build awesome REST APIs. You can build awesome gRPC APIs. You can develop on Linux on Windows. And now I'm going to switch over to David and let him show some containers.
Scott, before you switch, can you show the slide?
Yeah, happy to do that.
All right, so we're going to show a very simple microservice application. It's the weather application. And it's funny because service and application get used interchangeably. But by service, I mean an individual application, an individual thing that runs. An application is the overall end-to-end microservice. So I have a Blazor server front end that's going to be my UI that will show weather updates from the weather service. The weather service is going to pump updates over a gRPC stream to the Blazor server front end. And in the background, it will also send updates to Raspberry Pi climate control service. And the idea here is that .NET can run in multiple environments and places on Raspberry Pis, in the cloud, and locally. Let me switch to my machine now to show you this application. Start sharing. Can you see that? Minimize everyone. All right, so if I open up Visual Studio, you'll see the 3 applications that I had earlier in the diagram. Blazor Weather Server is the Blazor Server application. Climate Control is my fake Raspberry Pi that will become real as we go on further, and Weather. All right, so let's start with the Weather application because this is actually where the data is being created. So the Weather has a background service called Weather Worker. And Weather Worker is a background service that runs when the application boots up. And the goal of the Weather service is to ping a backend service called AccuWeather, which gives us weather information, and read the forecast and get the first object from that forecast. Now, since we're doing a keynote and we can't have failures, what we do is we use fake data. So we'll create a random value between 50 and 100 as our temperature. And here's the code that pings the Raspberry Pi Climate Control, giving it that weather information over a post on a background timer. And then we store the value in a cache locally on this machine. And the intent of that is to avoid having the clients, as a result of pinging us, having us hammer the background service. So we don't want to hammer AccuWeather so we can cache the results here. And that's done on some fixed interval. So every 5 seconds, you should see an update for the weather information.
Yeah, the way I think of that, David, is imagine you're paying to call that service, so that service can only handle so much load.
Right.
By caching it locally, you could have millions of clients call your application, but you're only calling that REST API, AccuWeather, once every 10 minutes or something like that.
So you're self-throttled, basically.
Yeah.
All right, so now we can go to the protocol, with the goal being that I want people to call me, so I want to expose a contract for my application. So here's the gRPC contract for the weather service. It has a get weather stream streaming API, so that this stream weather response returns a stream of responses in a long-lived connection, and get weather returns the latest value. And this is the actual weather schema. So I've defined my schema, I've defined my services, and now I can share this with anyone who wants to call me as a client. And if I look at the same tooling that Scott showed before, you'll see I have this wired up in the add connected service dialog. And you can see the weather profile is configured. It understands it. I can view the generated source code as before to see the goop that got created by adding that file. And if we look at the weather service under services, you'll see I have a derived weather service from Weatherbase. Getting the cache via dependency injection. And I'm going to implement get weather stream by doing an infinite loop, essentially, and waiting for the client to disconnect, because this is an infinite stream. And every 2 seconds, it'll pump out the latest cache value. And we basically do some work to translate the forecast coming from AccuWeather into the gRPC model. That's some code here. All right, so now we have our background service, we have our gRPC endpoint, and we have the data. So now the next part of this is to go to the client that calls that backend to figure out what it's doing. So here's Blazor Weather. It is a server-side Blazor application. And let's start by looking at the dependencies first. So the first thing I want to do is to be able to connect to that service. I have to add the same gRPC profile, but instead of generating the server, I care about the client. And Scott showed this in his previous demo. So I can do the same thing, see the code that was created by that tool, which isn't that important. And if I look at the core page, the forecast page, what it does is it's a Blazor application. So here's some HTML, and here's some UI that isn't that important right now, but here's the meat. When the page starts off, we call into the gRPC backend to get the first value for the weather, to get the snapshot. And then after render completes, we start a stream that is long-lived, that runs on this interval. So we call the get gRPC stream method, passing in empty and a cancellation token. And we use C#8, await for each to loop over the asynchronous stream. And every time there's a weather update, it'll update the current weather, and it will fire state change. State has changed. What it does, it'll make the UI change after seeing the update. So we can actually view the changes live in the UI.
This is
The
really
last,
cool, David. I love the fact that stream, the
yep,
server is really pushing the data to the client, not the client
yeah,
pulling the data. So whenever
exactly.
the server updates, the client updates.
Yep, that's one of the key features of gRPC actually. The end-to-end streaming between client and server in a standard way. It's a very nice feature. And there's some goop here to make it reconnect if it fails. So if I kill the backend or it dies, it has this back off where it kind of delays and retries. That isn't that important right now. And then the last service is our fake Raspberry Pi that we'll see later. So here's a simple top-level C#9 program that kind of has the same thing that Scott had where he showed his simple microservice, but it's doing a little bit more. This application is going to run on the Raspberry Pi, and it's going to get temperature updates, and it's going to print out either the temperature is too cold, too hot, or just right, based on the information passed to it. So it supports a simple route that's posed. It gets a variable. I parse out the value into a temporary variable, and I print out. Actually, I'm not sure if this is temporary or temperature, but it prints out the temperature and some sentiment. Is it too hot, too cold, or whatever? There's also a very fancy ML model being run on the server side, the weather classifier that classifies the weather based on the image passed in. And the default implementation is super advanced. There it is. Accurate, I say. All right, so let's say I want to run this now. So as we saw before, what Scott did is I want to run the front end. So I'll go to my console window and type in the Blazor weather server. I'll run this with .NET Run. It should start the application on port 56919. That port is always free.
Write that down.
I know. And I'll run it, and then didn't work. So the issue is I need to run the front end and the back end because this is a microservice, right? I have more than one that's required to run. So I could open up a second window, find the weather backend in .NET Run, or what if I told you that like magic, I could just run a command called, and by the way, ls, there's nothing here. There's no files. There's just a solution and nothing else, right? Just random stuff here in the root. If I run this, it'll do some magic behind the scenes. And it tells me there's a dashboard running on port 8000. So let's go there and see what it's doing. It's building projects. So I'll boot up the dashboard, and it's showing me now all my projects that I have in my solution running without any configuration at all. I can click on the Blazor weather server application, and it shows me the application running. So here's the application. It has the temperature and it has both. Oh, this feels better. This feels at home. Okay, good. So it has both Celsius and Fahrenheit, and it shows an update every 5 seconds from the background weather service. So the gRPC stream is pumping changes to the client, and the client is changing the UI based on what temperature it is.
Yeah, and I can see the updated changing just dynamically there, Dave. It's amazing.
Yeah, it's pretty cool, right? So see, it's cold now, so it went blue. And if you look at our ML model, it's working pretty well. So it's looking at this image and trying to figure out what the weather is, the sentiment. All right, so that works. And the other part of it, the dashboard shows me logs for every service. So I can look at my Blazor weather server and see logs in real time, see it update logs. See it's printing a debug call to get gRPC message. And then I can look at the weather service itself to see calls coming into it and calls going out of it. So I can see it posting to the Raspberry Pi the temperature on this fixed 5-second interval. And I can look at that device and see, it printing out blah is too hot, blah is too cold, blah is just right. All right, so I can see in my overall service running, all 3 services running, seeing logs. I can also see metrics. So I can look here and see counters. I can look to see if my application is performing properly. That's a pretty cool feature as well. And there's some more hidden stuff. And if you want to learn more about this, you can see the talk that Justin and Glenn are doing later today. But let me show you how this actually works. So I said I didn't have to make any changes. That was a little bit of a lie. I had to make one change. So I ran 3 applications, and I had to tell the Blazor front end about the back end. So how did that happen? So in startup, I'm using very standard APIs. There's nothing up my sleeve. And this is the old code. The old code was hard coding the address very carefully, handcrafted 5039 because that port is always free on every machine. And here I can instead call a helper that Ty had, which is get service URI, weather. So weather is the name of the service defined in the dashboard that I have here. It's based off the project name by default. And I can say, give me the URI for weather. And it doesn't matter where that comes from, right? It will be passed into the application on boot up, and it can discover where that is. So the port can change on every run, and it doesn't matter because the application isn't tied to that specific port. It's tied to a configuration value that Ty will pass into it.
And David, that port and IPs is going to change when you publish to the cloud as well. So this is resilient to publishing as well, right?
That's right. It works both locally and when you deploy. I'm going to show that as well. So weather, let's look at the weather. The weather does the same thing for climate control. So it talks to the Raspberry Pi by getting the climate control address and then publishing to it, right? So that all works great. Now, what if I told you I want to run this in a container? Well, what you would do is you would install Docker, you would learn the syntax, you would author Docker files for every single project, you would copy the content from the CS proj into Docker files. Basically, and there is great support in VS for like adding Docker support, right? So I could do this for my projects and then figure it out. Or I could Ty run -- Docker. And Ty understands .NET and understands what it means to build a container from a .NET application. So it can automate doing all the manual Docker file things for you. And you can see my application here is a project if you see in the faded UI. And if I refresh it now, it should change to, it should change to container. So there it is. So now I have my applications running locally. 3 of them still working with the same service discovery, running in Linux-based containers, no longer on my physical machine directly. And this is the same application with the same configuration, no code changes, running on a Linux container on my machine, right? I didn't have to configure a compose file. I didn't have to write any container file, Docker files. All I did was have a solution file with a bunch of services, and it ran.
Amazing. That's awesome. Just one command line switch and the whole app is running in containers.
Dashboard still works. Logs still work the same way. So it's the same feature set, just within containers now, right?
That's awesome.
So that's cool, but that isn't all. So what if I wanted to actually push this somewhere live, like on the internet, so everyone can hit it and destroy my demo in the keynote? So there's a command called Ty deploy that I won't run here now because it takes a little bit to run, but I can run it and it will load my application and it will ask me for where I want to push my containers. But I have a console app up here that has a previous deployment. So I ran Ty deploy, I passed in my Docker Hub account, and it found my services, it containerized them, it pushed them to Docker Hub, it created the Kubernetes manifest, and it pushed them to my active Kubernetes, which I have a cluster configured on Azure right now. And if I do a port forward, and the idea here is that I'm trying to basically show you my application running in the cloud, but I haven't exposed my application to the internet. So I can port forward a single service, the Blazor front end, to show you the application running remotely. Just to prove it, I can run kube control get pods. And here's the Blazor server application running in Kubernetes and Azure, all 3 services. And I port forwarded the Blazor server application to port 8006. And I made no code changes. So I have the same call to get service URI in my application. And Ty understands how to produce the right configuration for deployment. So you don't have to change the application when you run locally or when you deploy to Kubernetes. So here's the same app running live in Kubernetes, in Azure. And just to prove it a little bit more, I can show the logs of one of our containers running. So here's the climate control. It's too hot, it's too cold. Logs running directly in Kubernetes on Azure. And then for the finale, see, we're going pretty well here, right? I have one more thing to show you. So there is a Raspberry Pi running somewhere on someone's machine, somewhere in the clouds. and I can run Tye in it. So normally Tye can work off a solution file, but if you need more control, I can run Tye in it and produce a Tye YAML. A Tye YAML just describes what services I want to define in my application. And I'm going to make one small change. So here I have my Tye YAML. It has the weather service, which points to the weather project. Same for Blazor, same for climate control. So I have a Raspberry Pi running somewhere else in the cloud, and I can say, you know what? Swap out that one service for this external address. And this is to make that call to get service URI continue to work. So I'm defining this service, but I'm not defining how it's run. And if I Tye run this, Tye run, and I pop the dashboard again, it'll show 2 projects and 1 external. So now I have the app running, and it's going to this other random ngrok URL for the Raspberry Pi. So it's posting updates from the weather service to the ngrok URL, and that should show me, is it on the stream? Is it live?
It's live.
Oh, awesome. Is it updating? So now we should see the weather being synchronized on the Raspberry Pi with the weather in the Blazor application. And it's Celsius because that's what decent people use. No offense. And here is that's the final demo. So Tye can orchestrate services running both locally and remotely without you having to change your code in either situation.
Can we show the Pi?
Yeah. Is it not? Oops, my bad. How do is it on the stream?
I think Brady has to share, right?
It is currently it's running, and that is my camera that you see. I don't know if Jeff can make it bigger.
Jeff, can you make that bigger?
We have the camera up, and folks can see the Pi there on screen.
Oh, cool. Also, we can't see it, but it's on the screen. Okay, good. That's awesome.
Cool.
It's still too
Can
hot.
I take back over, David, for a second?
Yeah. Yep. Go ahead.
Okay. So I'll share real quick. Is that back up, Fritz?
Yes, sir.
Okay. Just to recap really quick, we showed a lot of stuff today. .NET's awesome performance, great for microservices. We have awesome support for REST and gRPC. We can make small single file exes that are small and use little less memory. With Tye, David just showed some amazing tech, building multi-part .NET applications, running them locally, running them in the cloud, running them on containers, running them on Raspberry Pis. You can just imagine the possibilities with Tye. And then with top-level C# programs, we showed that you can build APIs with a minimal amount of code. We'd like to say, enjoy the conference. There's a whole bunch of talks here on the screen. Please watch these as we called out today. If you want to really deep dive in Tye, some of the folks in the team are doing that later today. And finally, if you have any questions, ping us on Twitter. And with that, I think Brendan Burns is next.
Thanks.
And thank you.
Thank you, guys. Really appreciate you kicking us off with this keynote. There's a whole bunch of questions out there on Twitter already. We're going to take a quick break as we bring on Brendan, and I'm going to ask Scott and David if they can just check in with some of those questions that we have over on Twitter as we get Brendan ready to come on and start our next session. Thanks so much, guys.
Thank you.